refresh our memory of some of the cost concept. Okay. Probably you have seen those definitions earlier. Variable cost is defined as the minimal cost. Okay, I'm going to emphasize minimal because here we're dealing with this cost C. Okay, and this cost C. Okay, you can produce Y at this point, but your cost will be higher. What I'm talking about when I define variable cost, I refers to the minimal cost. Okay. The minimum cost to produce Y units of output in any particular production period. Okay, this means I can deal with a short run situation where there are some factors are fixed, some factors are variable, or I can deal with a long run situation where all factors are variable. Okay, variable cost depends on variable factor prices and output. Because what? Because the cost, minimum cost, depends on factor prices and output. Okay? And this dependency is described by the cost function we introduced earlier. Okay? So variable cost is exactly this cost function. Okay? Now we have an explicit definition of variable cost. It's minimal variable cost. Okay? It's R1 times the factor demand for factor 1. R2 times the quantity of factor 2. Okay, that's variable cost. Okay, variable cost is this cost function we derived earlier. Now, marginal cost. Marginal cost is defined as the additional cost incurred when output increases by infinitesimal amount. Okay, and here again, the cost, I mean the minimal cost. So now marginal cost is a partial derivative of this C, okay, minimal cost with respect to Y. Okay. On this graph, essentially what that means, if I increase my output target by an infinitesimal amount, how much my minimal cost will increase? Okay, that's marginal cost. Okay, that's kind of a little bit abstract. Let's use a example. Okay, let's use now we can assume we have one variable factor production function. Okay, Y is equal to A X B. So I have just one variable factor, okay? So with this, okay, let's first assume alpha is a number between 0 and 1. So this is kind of a one variable factor called Douglas function. Okay? The graph of that function is this, x, y. It's a concave production function because this parameter alpha is a number between 0 and 1. Okay. Well, the minimum cost, if y is given, and assume the price of x is r. R is the price. Okay. So in order to produce y, what is the cost? Variable cost. If you just have one variable factor. R times x, right? So because you have only one variable factor, there's no substitution anymore. So your total cost is Rx, but x is what? X is the inverse of this function, correct? Okay, so I can rewrite this as x is equal to y over a. So these two are equivalent, right? That basically means if I want to produce y, okay, my x is equal to this, y over a, power raised to 1 over alpha. That's the inverse function of this. Okay, as if you are kind of flip this over function. Put the x here, y here, then you have this function. Okay. So the variable cost is equal to r times x, where x is equal to this. So that's my r y over a, 1 over alpha. That's my variable cost function, the cost function. Okay. And to be explicit, let me write this as VC is equal to cost function depends on factor price R, output target Y. Okay. The same as we did over there, where we have two factors. So we have R1, R2, but in this case we just have R. And look at here, this function is depends on R and depends on Y. Okay. So that's my variable cost function. Okay. So what is the marginal cost? The partial derivative of this cost function with respect to Y. So partial of C with respect to Y. Okay. So if we want to take the partial of this function with respect to Y, what is that?
1 over alpha R.
1 over alpha R times 1 over A, 1 over alpha minus 1. Correct?
Isn't that like a composite function though, when you have to take the derivative?
Yeah.
So times
Thank
1.
you. So then you have to take the derivative of this term with respect to Y, which is 1 over A. Okay. So you can rewrite this as 1 over alpha. But this is a marginal cost curve, marginal cost function, okay? Well, let's just try to draw those graphs, the graphs of this function, okay? Let me use this. Okay. Put Y here and draw a 45-degree line. 45. Okay, so I'm mapping Y on the vertical axis to Y on the horizontal axis. So I have Y here and the cost here, variable cost here. Okay? And here, when I know X, R is given, okay? I can calculate my Rx, which is variable cost. Suppose the slope of this line is R, okay? So if I know X, so the cost is Rx, correct? So the cost function is, the cost is linearly dependent on X. So what I'm going to do is to choose the output target level. Try to figure out the variable cost, minimum variable cost. Okay? And I'm going to plot the Y here on this diagram here. Okay? On the horizontal axis. And this new variable cost on the vertical axis. Okay? So I'm going to choose 2 points or 3 points maybe, then we can link them up to trace out the variable cost curve. Okay? Let's start with this. So my first output target is Y here. Okay? So I'm going to first map my Y on this graph here.